We are now discussing layout of various types of substations. Single line diagrams are being used to represent different kV substations. In order to represent substation single line diagram, we'll be using various symbols to represent the various components of a substation. This is what being represented in the present slide. We observe here, whenever there is an earthing in the substation or anywhere, the earthing is represented with this particular symbol. A vertical line intersecting with a horizontal line. Then with some gap, we will have horizontal lines with decreasing size. This, whenever you see this symbol in any circuit, remember it is earthing. Current transformer. You know, to read high currents with ammeters of normal range, say 0 to 5 amperes or 0 to 10 amperes, we need to reduce the higher currents to currents that can be read by normal range ammeter. So we use a current transformer, which is often called as CT. So CT is represented like this, with a straight line crossing a single coil. Then, in the same way, in order to read voltage of very high values, to use normal voltmeters of the range 0 to 300 volts or 0 to 600 volts, we use potential transformers. The secondary of the potential transformer is connected to voltmeter. So the load is very less. So CTs and PTs are very small in size. Potential transformers are often called as PTs. And to represent potential transformer, we use this symbol, a line, circle, intersected by another circle, and again a line. Then we need fuse in any circuit for protection purpose and to disconnect the line in case of any problem. The fuse is sort of isolators are used for connecting and disconnecting a supply. A horizontal line with a gap running with an inclined line. If we operate this, the two lines will be closed. That's why it is called isolator. Then a tandem isolator with a curved line. Circuit breaker is represented with straight line in between two straight lines with a cross, the X mark in the middle. Bus bar is represented with a solid line. Whenever you observe a solid line in any network, means it is a bus bar. Lightning arrestor to protect the system for high voltages surging onto existing system. We need lightning arresters. This is a bit like this. Lightning arresters will be that you will see when you look at into single line diagram of a substation. Transformer is the heart of a substation. It is used either to step down the voltage or step up the voltage. The step down transformers are used in distribution substations. Step up transformers are used in generating or primary substations. At places, auto transformers may also be required. Auto transformer, as you know from transformers topic in electrical machines, Transformer will have two windings connected by a core. The two windings are primary winding and secondary windings. There will be a magnetic core. There is no electrical connection between the primary and secondary winding, but they are mutually coupled magnetically. Auto transformer is having a single winding which can be acted as both primary as well as secondary. In such a case, we represent it like this and like this. So, with the knowledge of all these symbols, we try to understand it. This is the layout of a 33 kV substation. Let us try to identify components based on the symbols we use. Earthing, CT, PT, fuse, isolator, tandem isolator, circuit breaker, bus bar, lightning arrestor, transformer, auto transformer. Now, we'll check. Yeah. We have one solid line, another solid line, another solid. So, what is this? This is a bus bar. This is a 33 kV bus bar. This is 11 kV bus bar, 11 kV bus bar. If you observe, what is the difference? 33 kV bus bar is drawn slightly thicker than 11 kV bus bar. We have isolator. We have circuit breaker. We have CT. Isolator, isolator. Circuit breaker, circuit breaker. Transformer, earthing, earthing, earthing. Transformers with appropriate earthing. Then we have potential transformers. We observe potential transformers here and here. CT, 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 CT. This is how we can identify various components of a substation. Now let us describe the single line diagram of a 33 kV substation. 33 kV substation means the substation is having 33 kV line as an input to it. And the 33 kV line is connected to a step-down transformer to feed various loads and conduits. So let us come here. It is a 33 kV incoming line. The incoming line is not solidly connected to actual bus bar of the substation, but it is connected through an isolator so that whenever we need some maintenance to be carried out in the substation, we will be disconnecting using this isolator. And we'll have a circuit breaker. What is the purpose of the circuit breaker? The circuit breaker, in case of any fault, will trip the circuit and protect the equipment from fault. Whenever the fault is corrected, the circuit breaker will reconnect the system into normal. To read the current values, we'll be using circuit or current transformer. The current transformer is to read higher values of currents to a reasonable value of current. Then, if you observe here, what does this symbol indicate? Lightning arrestor. Lightning arrestor is earth, you remember. What is the purpose of this lightning arrestor? In case of any lightning arrestor will take the extra voltage or the high voltage due to lightning surge to be bypassed to earth to safeguard the system. Here we have 33 kV bus bar. What is the meaning of this 33 kV bus bar? The 33 kV bus bar is having an incoming line of 33 kV. The 33 kV bus bar is having outgoing lines. So the bus bar is having incoming and outgoing lines. To this, we are having incoming line. From this, we are drawing outgoing lines. Then there are two outgoing lines from this bus bar. Where are they going? They are going to two transformers. What are those transformers doing? The transformers are stepping down the 33 kV to 11 kV. 33 kV to 11 kV. So transformer number one, transformer number. Of course, before the transformer or in between the bus bar and transformer, we have isolator and circuit breaker. Isolator and circuit breaker. So after this transformer, the lines are 11 kV lines. The 11 kV lines are running out from the transformer and they are connected to again bus bars. This is the 11 kV bus bar and this is also a 11 kV bus bar. So we just try to understand again what are various things happening at these two 11 kV bus bars. Two transformers are feeding two bus bars, 11 kV bus bars. If you observe on the top, both 11 kV bus bars are connected to PTs. What is the reason? To monitor and measure the voltage available at the bus bar. And if you observe, we have continuously circuit breakers. So from the when we draw output from these bus bars, or when we take input to this bus bar, we provide circuit breakers which will protect the system in case of any fault. We have capacitor banks for kV power factor compensation. We have various other supply lines that can be fed for stepping down the voltage further to meet normal loads, connecting the line to various commercial and industrial loads. Now, with this basic setup for a 33 kV substation being understood, we'll move on to the next substation, which is a 66 kV substation. 66 kilovolts substation. So, if you observe here, you have a 60 kilovolt incoming bus, and the incoming bus is connected with an isolator. Incoming line is connected to 66 kV bus. See the long bus, 66 kV bus. With the help of an isolator, it is connected to it. So the 66 kV bus bar is connected to bus PT to measure the voltage maintained on the 66 kV bus. Then we'll come from this side. We have 66 kilovolts of isolator followed by oil circuit breaker followed by current transformer followed by an isolator and a lightning arrestor. Then it is connected to a transformer. What is this transformer? 66 by 11 kV transformer. This is transformer number 1. So the other side of the transformer is a 11 kV supply, and the 11 kV line is being taken through a cable, and the cable is now being connected to a 11 kV bus bar. If you observe, it is connected to a 11 kV bus bar. Immediately, when we have a bus bar, if you observe, we have bus potential transformer. Before it is connected to it, it is being connected to a current transformer to read the current, the circuit breaker to protect the system. And these are all the outgoing lines from the 11 kV bus bar. See, the first 11 kV bus bar is first being taken through a 11 kV outgoing line through a circuit breaker and current transformers. Through a circuit breaker and third 11 kV outgoing line to circuit breaker and current. Then 11 kV capacitor back to compensate power factor again through the circuit breaker and current transfer. Then 11 kV outgoing line through a circuit breaker and current transfer. Another 11 kV outgoing, another 11 kV outgoing line, another 11 kV outgoing line. And here in the last line, if you observe, we are having a transformer. The transformer is from 11,000 volts to 415 or 440 volts, which is used as a distribution transformer. So domestic consumers and the consumers that use electricity at low voltage will be supplied using this transformer. And if you observe the 66 kV bus, we have another setup here. 66 kV isolator followed by a lightning arrestor immediately, then an oil circuit breaker, then a current transformer, again an isolator connected to a transformer. Transformer is properly earthed. The 33 kV output of the transformer is supplied to next level lines. So all the loads you observe here are being fed by 11 kV lines, but here the loads are supplied at 33 kV. So the 66 kV line coming into the substation is used to feed various loads who are operating at 11 kV, 415 kV, 33. So this is what we can learn from a 66 kV substation. Now we'll take up or we'll move on to the next level of substation. It is a 220 kV substation. Two 220 kV substation. See, 220 kV main bus 1, 220 kV main bus 2, 220 kV transfer bus. So the two main buses are connected to ETs. They are all connected through bus couplers. See, they are having couplers. The purpose of bus coupler is to connect or disconnect the various buses. We have a bus coupler in our college substation. Whenever you visit our college, you remind me to show you all the components of a substation. I myself have done the task of connecting bus bar through a bus coupler to use different transformers in synchronization to have effective utilization and minimal losses in the transformer. That is what I personally have practiced in our own substation. Instead of increasing the installed capacity of the transformer, I have proposed using two transformers of lower rating instead of going for a single transformer of higher rating, to take the advantage of operating the transformers at higher efficiency and to maintain the power factor to be reasonable. I proposed that, and our management have consented gave consent, and we could proceed with adequate arrangements required to operate the loads. Afterwards, we could have our own solar plant, which I myself have developed to the full capacity, and our plant is in operation. Usually, we used to get 5 lakhs to 6 lakhs electricity bill before the installation of our solar plant. After the installation of solar plant, if you want to know, uh, for the last month, the electricity bill we have paid is only 17,000 rupees. That's how I feel very happy because it's my own interest and involvement in the establishment of 250 kilowatt solar plant in our college, which made use of the natural resource, which causes no pollution at all, simply making no noise, making use of the radiation available to the sun, generating electricity, and making use of the electricity to meet various loads of our college. As in the previous month, as there is no load, as we are not in college, the full capacity generation of our solar plant is being exported to local distribution company, and we could save almost the load cost also, which will be coming around 1.5 lakhs. We paid only 17,000 rupees. So, if we are interested to understand and execute practical aspects of electrical engineering, we get the satisfaction not just by saving money, but also by contributing a decent amount towards global warming. We are helping reducing the pollution by way of combustion of coal, and we are thus helping the next generations to have a better environment, to stay in a better environment. So the bus coupler has a specific reason to be connected to interconnect various buses. So here it is 220 kV. Using transformers, it is stepped down to 132 kV. And again, the 132 kV buses are used to step down to 33 kV, and they are connected to normal. That's how it is. All these things are very important. Now, when we discuss the single line diagram of these substations, we should also be aware of various equipment for a substation and switchgear installations. So these are the things we find in a substation: bus bars, station insulators, switchgear, power transformer, uses, instrument transformers, protective relays, lighting arresters, indicating and metering instruments, batteries, carrier current equipment, control. Bus bar, as we know, is the one that is connected with input line and feeds various outgoing lines. Then station insulators are different types. There are hose type insulators, bushings. There are many types that are used in a substation. Switchgear is to connect or disconnect the supply and the system. It uses several switches, which are called air brake switch, oil switch, and isolators. And it also needs interlocking between poles for simultaneous operation, interlocking with circuit breakers, load interrupter switches, earthing switch. Now, there is a sequence of operations for opening and closing the circuit. While opening, open circuit breaker, open isolator, and then close I think so. While closing, open earth switch, close isolator, and then close circuit. Right. So the next component we come across in a substation is power transfer. Power transformer are transformers that are used to step down higher voltage to lower voltage so that various types of consumers are connected. Step up by lower voltage to higher voltage in the primary substrate or generating substrate. Fuses. We'll be studying fuses in detail in switchgear protection circuit. Fuses are used for protecting the circuit during high voltage. Instrument transformers are for the purpose of measuring current and voltage. Current transformers and potential transformers. Protective relays. Protective relays are already discussed. They are for protecting the circuit from various faults. Lightning arresters are to bypass the high voltage that possibly impacting the main lines by arresting them. Their lightning arresters. Indicating and metering instruments are ammeters, voltmeters, wattmeters, kWh meters, kVRH meters, power factor meters, reactive voltmeter meters, etc. are called indicating and metering instruments. Batteries. So what is the need of batteries? Now, in any electric power station, or the operation of automatic control equipment, it means backup supply. You need therefore batteries. Carrier current equipment. The carrier current equipment is installed in a substation for computation, communication, relaying, telemetry, or for supervisory. This equipment is suitably mounted in a room known as carrier room, connected to the high voltage power circuit. Control cables, the last one is control cable. The control cables and conduit systems are required for affecting automatic automatic controls. The control systems generally operates at 110 volts or 230 volts. The cables employed for this purpose are multi-core cables having 10 or 37 or 61 conductors according to the requirement. For laying these cables, generally ducts are run from control room basement to centrally located junction box, from where the conduits are run to the required points. So this is what we need to learn the electric is in substation. So you try to understand about these components within Google or any textbook, and we'll discuss substation auxiliary supply and the substation earthing concepts in the next class.